Everyone, I'm so sorry we're back online. But yeah, just we're going to start off this year with chapter 7 indices. So this is book 2. Um, Everything in book 2 starts with a revision of what happened in book 1 anyway. So we didn't actually get to indices in book 1. But it doesn't matter because I'm going to include the stuff in book 1 into this chapter. Okay, so we are a little bit behind, obviously, with everything that happened last year. We're maybe 4 chapters behind. Um, so we'll just have to kind of pick up the pace or whatever to try and get through those 4 chapters this year. The Junior Cert Higher Level Maths course is long, so we will have to work quite hard to complete them. But like, I've no doubt that we can do it. We will just have to work kind of at a decent pace. So hopefully, you know, back in the classroom as normal soon enough. Okay, so indices. First thing I suppose is, what is an indice? So if I gave you something like 3 to the power of 4, okay, so that's something you've seen before. You would have done stuff like this in first year. You have the number 3, you're raising it to this power here. So essentially what that means is 1, 2, 3, 4 threes. So it's 3 multiplied by itself 4 times. Yeah? So I just want to talk about the names of these, okay? So this one here is referred to as the base number. Now, this one here, okay? That, as we know it so far, is called a power. Okay? But there are other names for it. One of the other names is an index, and the word indice is just the plural of the word index. And then there is another one, which is an exponent. Okay, so an exponent is another word for a power. Okay, so when we talk about indices, essentially what we're talking about is powers. Okay, now indices are governed under a list of rules. They're just called the indice rules. So this formula and tables book, which you're all supposed to have, if I go to the contents page, which is here, you'll see here indices and logarithms on page 21. So I'm going to go to here we are, page 21. And down here on the left hand side are the indice rules. Okay, over here is the other thing, the logarithms. Don't need them till Lee insert. And they're only on the higher level course. So all you're concerned about is the left hand side of the page here, and there are, I thought there were 8 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9 apparently. Okay, so what we're going to do is work through these rules one by one. It is literally sort of like a playbook on how to handle indices. Okay, and it's just a case of you get a question, you look in here, and you pick the one that's appropriate to you. Now, because this is a formula book, they have to give everything in general terms. So you can see here, there's not, besides 1, there's not a number in sight. Okay, it's all done in general terms, which means it's done using letters, variables, which you're familiar with. Okay, so I'm going to start up at the top here, rule number 1, and I'm literally going to write this down just as it is. Okay, so rule number 1 in the table book is A to the P, A to the Q, and it says A, P plus Q. Okay, that's what the table book says. So let's see, can we interpret that? All right, I'm going to like break the code type thing. All right, so what we have here is some number raised to the power of some other number. Okay, so let's go with 2 to the power of 3. Now, it could be anything, like literally anything. I'm just picking, I am saying that A, just use a bit of colour here, I'm saying that A is 2, and I'm saying that P is 3. Okay? Now, here, there is no operation. Okay, so operation, what I mean is plus, minus, multiply, and divide. Okay, they're your operations. There's no operation here. And there is only one operation that can be left out and it still makes sense. Now, we talked about this a bit last year, okay? So the only one is multiply. Okay, so I can write something like 3x, and I know that that means 3 multiplied by x. Or I can write like AB, and I know that means A multiplied by B. Okay, if they wanted me to add the 3 and the x, they would put a plus in. If they wanted me to subtract, they would put a minus in. And if they wanted me to divide, they would either put the divide sign in, or they would write it as a fraction, like that, which also indicates divide. Okay, if you want, or if a question wants us to do any of these 3 operations, they must use the symbol associated with that operation. The only one that gets away with no symbol whatsoever is multiplication. Okay, so essentially, while it doesn't have it, this is a to the p multiplied by a to the q. Okay, and again, we talked about that. They don't use the multiply sign where they can, like, they don't use the multiply sign when they don't need to, because it can be misinterpreted as an algebraic x as opposed to a multiply. So that's why they don't use it, and that's why it's kind of acceptable to leave it out. Okay, so what I have is I've made my A 2 and I've made my P 3. I know there is an invisible multiply here, so I'm going to put that in. Now, notice here that we have the A here again. Okay, so I've already decided what A was and I have to stick with it. Okay, so another 2. And then Q, so that's different to the P, so I'll pick something different. So let's pick 4. Yeah? Now, let's look at this problem, okay? Forget about what it says over here. Let's just look at the problem. So 2 to the power of 3 means 1, 2, 3 2's multiplied together. Yeah? So this is equivalent to this. We have our multiply. And let's do this one. So it's 1, 2, 3, 4. Yeah? So again, this here is equivalent to this. Okay, so let's see how many we have. We have 1, 2, 3, 4, 5, 6, 7. So that is 2 to the power of 7. And if you want, you can type that into your calculator and figure out what 2 to the power of 7 is. It'd be quite a big number. Okay, now let's look at the rule. What did the rule say? The rule said that if you have a base raised to a power multiplied by the same base raised to a power, you can just add the powers. So I didn't need to do this line at all. What I could have done is kept my base, which is 2, and added the first power and the second power. So 3 plus 4, which is 2 to the power of 7. And that's what I got when I did the problem out using 3 2's and 4 2's. Okay, so what this rule gives you is just a quick way to deal with something instead of having to expand it out and write all of the 2's. Okay, so if I had 4 to the power of 2 multiplied by 4 to the power of 6, for example. Okay, the quick way, according to the rule, would be to add this one and this one. So I'm suggesting, using the rule, that the answer is 4 to the power of 8. We can do it out. So this one would be 1 4, 2 4's. This multiply sign we still have to put in, so that's that. And then this one is 1, 2, 3, 4, 5, 6. How many do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. 4 to the power of 8. Okay, so what that first rule gives me is a quick way of doing this expanded version. Okay, so that's the first rule. I'm going to go on and do the second rule because it's similar. So we go and have a look at what it says in the table book. So here we are, rule number 2. It says a to the p divided by a to the q equals a to the p minus q. Alright, so we'll write that down. A to the p divided by a, oh, that looks like a q. Let's delete that, sorry now. here. And that equals a to the p minus q according to the table book. Okay, so again, let's throw in some numbers. Oh, I don't know, I'll go 5 this time. So 5 is going to be my base, and I'm going to raise it to the power of 6. Here, no issue with a lack of operation. We can clearly see that it's divide. On the bottom, base is the same. It is actually, for the most part in indices, it's quite important that the bases match. If the bases don't match, most of the rules don't apply. Okay, so having bases matching in indices is quite normal and it's accepted, and you have your matching bases. It means you can kind of plow on and do your question. We will move on to what are called indice equations, and the first step in those questions is to get the bases matching, because you can't apply any rules without the matching bases. There's, I think, the last two rules, 8 and 9, kind of help you when the bases don't match in a very limited number of situations, but for the most part, to be able to do any good work with indices, you need matching bases. Okay, so it's quite usual for the bases to match. So I have my base A and my base A, and I've decided that they're 5s, and again, I'm picking these numbers out of the air. They could be anything. I said that P was 6, and I'm going to say that Q is 2. Okay, so again, we're going to forget about the right hand side, and we're going to try and do it the old fashioned way. So 5 to the power of 6 is 1, 2, 3, 4, 5, 6. And then the bottom line, sorry, not very straight. Bottom line is 5 to the power of 2, which is 2 of them. Yeah? So if I pair, right? So I have a 5 here divided by a 5 here. Okay, so 5 divided by 5 is 1, which isn't going to make any difference. Like if you multiply anything by 1, 1 is the identity. So if you multiply a 5 by 1, you're just going to get a 5, or a 10 by 1, you're just going to get a 10. Okay, so essentially what happens is that 5 on top cancels out with that 5 on the bottom, and it leaves a 1 in its place, which is not going to affect anything. And then likewise here, I have a 5 here that can pair up with a 5 here and give you that 1 again. So they will, I've lost my thing, they will cancel out to give you a 1. Okay, so I'm left then with 1, 2, 3, 4 of them. So 5 to the power of 4. Okay, and it's obviously multiplied by 1 and multiplied by 1, but multiplying by those 1s is not going to make any difference. So it's just 5 to the power of 4 is my answer. And again, if you want to, you can go on and actually get a final answer for that. I have my calculator here actually. So just out of interest, 5 to the power of 4 is 625. Okay, but really, when you're working in indices, most of the time your answer is in indices. So the question will say something like, leave your answer in index form, or it might say, put your answer in the form 5 to the power of x, something like that. So, like, most of the time when you're working in indices, your answers will be in indices. You don't actually go on that last step. But I mean, it's not wrong to do it, it's just not required, I suppose. Okay, so I started with my rule. I stuck in some random numbers just so we could test the rule. And then I expanded them the way you would have been taught indices in first year when you learned what a power was. So I did 6 5s up on top because the 5 was to the power of 6. And then at the bottom I only had 2 of them. And then one of the 5s in the bottom pairs with one of the 5s in the top, and 5 divided by 5 is 1, so they cancel out. And same then, we had another one on the bottom which paired up with 1 on the top, and 5 divided by 5 is 1, so they're cancelled. So I was left with 4. Okay, so then let's try it using the rule. Alright, so it was 5 to the power of 6 divided by 5 to the power of 2, and according to the rule, if you have a division, you do keep the base. So there, look, the base hasn't changed. So I'm going to keep the base, and I'm going to do P minus Q. So that's the top power minus the bottom power. So the top power minus the bottom power. And 6 minus 2 is 4. Okay, so whether I do it by expanding out the powers or applying the rule, I get the same answer. So again, it is just a quicker way of doing the exact same thing. Okay, so that's the first two rules. So, sorry, this way. What we will do is I'll put together a couple of questions from your book based on those first two rules. Yeah, there's a couple there. It tells you what law to use, like makes it quite straightforward. So we look at those, and I will give you the ones with the minus because I sort of want to see what you do with those. We would have discussed this last year. I can't remember when we did this, but essentially, if you're raising, so if you've minus 5, say, raised to the power of 3. Okay, let's just take that one, go back here. So if you have a minus 5 raised to the power of 3, that is minus 5 once, twice, 3 times. Okay, so again, because this is indices, we don't really care about what this is. So how many 5s do we have? We have 1, 2, 3, so that's 5 cubed. Then you have to look at the signs. Okay, so again, we did lots of work on signs last year. So you have a minus, and those, when you multiply two numbers with the same sign, you get a plus. Okay, so these first two minus 5s will combine to make a plus. But then you're going to take this plus and multiply it with this minus, and when you do different signs, that gives you a minus, which means overall the answer to this would be a negative 5 cubed. Okay, if I try, I don't know, minus 6, say, to the power of 4. Okay, so that's 1, 2, 3, 4. Okay, so again, we don't really care what the answer is. There are 1, 2, 3, 4 6s, so that's 6 to the power of 4. Now let's look at the signs. So this one and this one, that is the same sign, and the same sign will give you a positive. Okay, now if you take this positive and multiply it by the next sign, now we're talking about different signs, which gives us a minus. But then you're going to take this one and multiply it by this one. Signs are the same again, which means you're back to plus. So overall, this one is a positive 6 to the power of 4. Okay, so it's just about looking at the signs. Now, the general rule is, you probably already know this because, again, we did discuss this last year. If it's odd, it's going to be negative. So if it's odd, it's going to be negative. If it's even, it's going to be plus. Even is plus. Okay, so I'll put together a couple of questions there on the first two rules. So first rule being when you multiply two bases and their powers, you add the powers is the quick way of doing it. And rule number 2 is when you're dividing, you subtract the powers. Okay, so that's rule 1 and rule 2. We'll practice a few questions on those before moving on to rule 3 and 4.